I'd like to tell you today about testing Android application from user interface perspective. So, how many of you write automated tests? Okay, pretty much in comparison with other conferences. Okay, today I'll show you many samples from different applications, and these samples will be written in Kotlin. I hope it will be not a problem, because syntaxes will be almost the same as in Java, and the popularity of Kotlin is growing now, and I hope it will be pretty understandable for everyone. Let's start with Android. Android, as any other platform, has many dependencies and complications. Let's start with dependencies. We have dependency to local and remote storage, device or emulator, dynamic permission, etc. Next, Android specific case that we have many vendors which produce mobile devices, use different version of Android, and really often they customize stock Android, and we have many different ROM from different vendors. And sometimes you can have problems that some of your feature or part of it can work correctly on some devices. And the last problem connected with whole software development process, that many companies test application in manual way or don't test. And today I'll show how we can fix this situation in Android. Really often development features start from the very beginning, and you add some screen to your application. And here you see a really simple screen. This screen have just map and few controls. And you can ask me, why should we write tests if we can check it in matter of seconds? And the main problem is that application is growing, and one day will be a really big problem test your application manually, or even it will be possible you will spend too much time on it. And here automated tests can help us with this problem and increase speed and development process. In Android, generally we have two different categories of tests, and they are different from requirements and time. First of all, local tests will be pretty fast because we run this test on the local JVM. We don't need to install different applications. I mean, main application and test application. And the next part that we have instrumentation test. This test require device or emulator. And we should split all instrumentation tests for two different parts. Is test which use UI for interaction with application, and non-UI instrumentation test. Non-UI instrumentation test will be much faster. However, we need install different application to device, collect test, run it in device, and come back result. Right now, we more or less know which categories of test and way of testing we have in Android, and how we can test it efficiently. Many companies around the world use this concept, which called testing pyramid, and main idea here is that we split all bunches of tests for three different layers. It's unit, integration, and acceptance or end-to-end test. As you can see, each layer have different size. In practice, really often it's 70% of unit test, 20% of integration test, of course more or less because it's just calculation, and something like 10% of acceptance or end-to-end test. Let's start from the unit test. In unit test, we check how different units work in isolation, and here we often test some business logic in our application if we use something like this, and we can use this framework GUnit. Often in unit test we need some framework for mock object. It can be Mockita, Gmock, EasyMock, etc. If our unit use Android framework, we can use Roboelectric framework, and I recommend use some additional matcher with matchers like Hamcrest. Moving to integration test, here we check how our units work together, and here we have almost the same framework plus instrumentation API. Instrumentation API is part of Android framework, and it allows us run our test on device or on devices and emulators. And last one is acceptance and end-to-end test. And here we check how our application works from user interface perspective. And here we have Android framework like UIAutomator, Robotium, and Espresso, and cross-platform frameworks like Appium, Calabash, etc. Today we will mostly talk about UIAutomator and Espresso. This framework was created by Google, and if you use something like Robotium and Calabash, I strongly recommend move to something else, because these frameworks are deprecated and not improving anymore. Maybe not deprecated, but not improving. Fortunately, we have a solution which allows us to test our application efficiently, and this solution called Android Testing Support Library. And here we have 4 basic components. It's Android GUnit Runner, set of predefined for Android GUnit Rules, and 2 frameworks for UI testing, Espresso and UIAutomator. Before moving to these components, let's check how what is going on when we press Run Test button on Android Studio. Under the hood, Android Studio called ADB shell IAM instrument command and installed 2 applications to our device. It's main application and test application. Test application contains Android GUnit Runner, Android Manifest, and all test cases. Android GUnit Runners interact with instrumentation API, which is part of Android framework and Android system, and interact with our main application. The main thing is that these 2 applications runs in the same process, but really often always in different threads, and it allows our test application interact with our main application. Android GUnit Runners fully support GUnit 4. GUnit 5 is compatible with GUnit 4. It means that we can use GUnit 5 with our instrumentation test, and this runner collects all tests, execute on device or emulator, on different devices, and report back results to our CI server or our workstation. Next thing is predefined GUnit rules, and by default we have all default GUnit rules, but it's not enough for Android testing, and we have rules for basic Android components like activity, intent, service, content provider, and finally was added for grant permissions. Let's take a look to grant permission rule. First of all, we should create our rule and call method grant, and here we can pass permission which we need. And this is really a great rule, because we always should test how our application works with all permission, without any permission, and with partially permissions. When we start to talk about rules, as you can see here, we have 2 different rules, and we can add to some modules many different rules. Do you have any idea in which sequence this rule will be called? It's not defined, but this rule probably will be called in this sequence. Why probably? Because it's depends on JVM. Each object has hash code, and it's depend of hash code for different objects. If you stop your JVM and run it again, sequence can be different. And of course, it's not a really cool solution for us, and we can use rule chain. In rule chain, we define this sequence, and sequence will be always the same. Here we use log rule. It's a simple rule which adds some log before and after test. It was general, mostly GUnit questions, and here we check how we can work with it efficiently on Android. We have default GUnit rules temporary folder, which creates a temporary folder before test and remove it after it. But unfortunately, on Android, if we would like to create this folder, we should have permissions for writing and reading external storage, if we need external storage, of course. And here we can create rule chain, where firstly we add permission to our device, and finally we can handle our folder create and remove files. And this code from real production application, and it's work correctly without any problem. And here sample how we can create custom rules. This is our log rule, which just add log, run our test, and finally add additional log when our test finished. And let's move to Espresso. This is a framework for UI testing, and we can test many things connected with many things inside the application. Fortunately, we have really cool API. It's API 8. Right now, it's 100% of active devices from last version of Android dashboard. This framework analyzes view hierarchy, and we can interact with all view from view hierarchy. But unfortunately, by default, we cannot work in a good way with some rendered stuff. It can be game, map, or something like this. And Espresso also have really cool thing which called synchronization. Right now, we can write our test without sleeps, fortunately. And but we should adapt our application for it. And when I talk about adaptation, I mean that we should turn off all animations. In documentation, in official documentation, you can read that we should turn off all system animation. But it doesn't mean that all animation for all application will be turned off. We should do it manually. And I'll show how we can do it. And let's move to Espresso. In Espresso, we can interact and check some properties in different views. And Espresso has two base methods. It's onView and onData. Let's start with onView. And here we have three basic components: viewMatcher, viewAction, and viewAssertion. We need viewMatcher for look for a view, viewAction for doing some actions with this view, click, double click, etc. And viewAssertion for check some properties in our view. When we called onView plus viewMatcher, we create view interaction object, which we need firstly for synchronization and secondly for interaction with different views. Here we have sample, and here we are looking for a view with ID name, and after it just type some text. And finally, we check that our pay button is displayed and just click on it. As you can see, it's pretty readable. However, right now you can find many different wrappers, which allows you write much shorter. You can find it as for Java and Kotlin. For Kotlin, it will be mostly with Kotlin DSL, but it allows you reduce amount of code which you need to write for testing some UI stuff. Espresso closely integrated with Hamcrest. This library have many different matchers, and I would like to show you how we can use it. Here we have simple Espresso code, and we use this text matcher. And this text matcher can use plain text, resources, or some Hamcrest matchers. And in this sample, we check our payment view and check that our text will be the same as Go or starts or end with Go. Sometimes when you get some data from your real server, this start or end with can help you with testing, because sometimes you can know not just part of string, part of object, and it can really help you. Here we have a simple example with login screen. First of all, we should create activity test rule for our login activity, and here we have a test, And first of all, we are looking for a view with edit text, email, type text, and close the keyboard. Next step is to press login button, and finally we check that our password text layout has an error. Here we use with error matcher. It's our custom matcher, and I strongly recommend create different custom matchers, because one day your application will be updated, and if you use many the same code, many repetitions, you will have problem, because you should update too many things at one time. And if you use matcher, you just update your matcher and everything works correctly. Here, really often in Espresso testing, we use with ID. We also matcher. We also can use with text, with hint, etc. The main really often we use ID, because ID is something unique on our screen. Of course, except situation when we talk about different items in our list, because in this case, ID of this item will be the same. But unfortunately, sometimes we cannot set some views, some ID for different views. Really good sample, it's snack bar. And here we use with ID and really long package plus ID of our snack bar. And unfortunately, it's not pretty understandable which ID of some components will be in practice. And for it, first of all, we of course can check the implementation of snack bar. Probably it's not really good idea. And second way, use UIAutomator Viewer. And I'll show you this tool and tell you a little bit about it. And here we are looking view with our snack bar, and finally check the text as snack bar text, the same as we have in download movie info constant. The most popular view in many applications is list. In Android, we have two basic implementation of lists. It's implementation based on adapter view and view group. When we talk in adapter view implementation, it will be list view, spinner, grid view, and much more. And for all these views, we should use onData method, because we store onData in adapter and not display all data in the screen. And when we use onData for interaction with a different adapter view widgets, we can scroll it and interact with item which not display right now on the screen. And here we have two additional objects. It's object matcher and data options. And it helps us to find a required item on the adapter. Here we have an instance when we use array adapter of string, and here we are looking for all object which is string and Americana, and it's display. Right now we have it. But in practice, we almost never use array adapter of base string in our production application. And for it, but we would like to test it. And here we should extend our adapter and override getItem method. And this getItem method should return some type. If this method will return string, you can test it in the same way, because it will be string. In my case, getItem method to return coffee object. And here we use a custom matcher. To my point of view, it's really good. From my point of view, it's really good practice to use something like this. And here we took we help Espresso where Espresso should find our item in which component. And here implementation of with coffee matcher. Here we use bounded matcher, and it's matcher from Hamcrest library. And many matchers from this library have two methods. It's describe to and match safely. Match safely allow us to match expected and actual object, maybe with some additional manipulations, and describe to just add additional login information when your test fails because of this matcher. As you can see, recycler view, it's a second implementation of list. It's not an adapter view. He implements view group, and we can use on view method here. Fortunately, we have many different actions, which we can use just with recycler view. As example, scroll to position action on item. And as you can see here, we are looking for recycler view and do some actions at position. Of course, you can create custom action assertions and matchers, as I showed before. Coming back to one of main benefits of Espresso, which is synchronization, and how synchronization works under the hood. Firstly, we need to create a view interaction object. It's on view plus view matcher, and after it, this interaction await when message queue will be empty, and Espresso wait for reasonable time. By default, it's, if I remember correctly, something like 50 milliseconds, but we can customize it. Next thing is that Espresso wait for no active async task and no active idling resources. And it means that if you update something on the screen, message queue will have some object, and Espresso will just wait on it. But sometimes it's not enough because we can get different objects from another application which work in different processes, and in this way we can create something like idling resource. Idling resource, it's a mechanism which allows you to wait for some event. In Espresso, we have two basic implementations of idling resources. First of all, we can create custom idling resource based on idling resource interface, and for it we should override three different methods. It's get item, is idle now, and register idle transaction callback. Let's start with callback. This callback we get from Espresso frameworks, and use is in idle now method. This method checks that check some state or check some conditions to understand that your application or some view is idle now. And you should understand that we should override get name method, and this get name method should have unique should return unique string, because Espresso identify different idling resources by name. And if you will have two idling resources with the same name, you can have flaky test. And of course, it's not a great solution. Right now, we have some idling resource, but how we can use it in our test? First of all, before or inside our test, we should create our idling resource and register it before test and unregister after test. And in our test, we don't care about synchronization if our idling resource idling resources are written correctly, and just do interaction with our application. Counting idling resource, it's a little bit another story, and here main idea is that we should create a counting idling resource object inside our application. By default, counting idle resource object has value 0, and Espresso will wait for the moment when this value is not a 0. As example, when we load some data, we increment this value, and right now it's 1. When we displayed some data, we can decrement it. Right now it's 0. Espresso stop wait and start some interaction or check-in on our UI. About using this object, it's almost the same. The one difference is that we should get our idling resource from activity. Its other stuff is totally the same. Uh, all applications, or almost all, except Hello World, have many different screens. And start always with the main screen. It's not really a great idea, because first of all, we spend too much time for some navigations. If we run if you run your main screen and you would like to test some settings, start from the main screen. It's not really a great idea, and we can start from different activities. If your application have one activity and many fragments, you can create your test activity and just add to your test activity some fragments. And in this way, you can test it without any problem. For start your application from different activities, we should use another constructor of activity test rules. First of all, it should be class and two Boolean parameters. First of all, first parameter should be true, because it means that we would like to use by default touch interface. And of course, it should be true because Espresso interact with our application, use touch interface. And second parameter should be false, because it means that we would like to doesn't run our screen, our activity before test. And in test, we can create some intent, put some data to this intent, and start our activity with this intent. And it helps you start your test from different screens. And it helps you reduce time of your test. As I said at the beginning, we should handle our animation in our application properly. Because when we turn off all system animations, it doesn't mean that all animations in all applications will be off. We should get animation speed or another object from global settings with a content resolver, some settings name, and for us is interesting animation duration scale, transaction animation scale, and window animation scale. And if this value is 0, in your application you should turn off all animations. It helps you reduce number of flaky tests, and you can do it just for debug application, and your production application don't care about different stuff connected with applications. But it helps you test properly, because sometimes people tell that Espresso have really huge problem with animations. I think Espresso haven't problem with animations. We just should adapt our application for using this framework. UIAutomator Viewer, it's really cool tool which allows us get information about each view on the screen. It's part of Android SDK. It means that we can use it from Android Studio or run it as a separate application. You should connect some device or emulator. Scan screen. It's scan all screen, and here you have a whole view hierarchy, and you can choose some view and get detailed information about it. Here you can get a resource ID, content description, text, index, is view clickable, checkable, etc. And in this way, we can get information about ID of different views, as example, snack bar. And move to the second framework of Android testing support library. This is not really popular framework, and one reason is API, which is pretty high. And but this framework has really cool things that it means that we can interact with any application in a system. And sometimes when you would like to test something and get some intent from different application, and you create a browser, and you would like to check if you click to some link, and this page will be displayed on your browser. And it's impossible to test with Espresso, because with Espresso we can interact just inside our application, and it's all. With UIAutomator, we can interact with all applications with software and hardware buttons, which is also impossible. With Espresso. Here we have pretty simple instance of testing calculator application. And main idea here is that first of all we should create UI device object, press home, and right now we are on main screen. And if you test your application in this way, you should also close your application after the test, because if some another application will have some state and you just open and start interact, it also can be a flaky test. Next step that we are looking for a view with app list description. Click on it. We have a list of application. Next step, we are looking for a view with calculator description. Also click, and our application is starting. Unfortunately, this framework doesn't have any synchronization, and it means that we should set maximum timeout for rendering. If this task will be done for 100 milliseconds, it's done by 100 milliseconds and go to the next step. After it, we create all objects which we need for interaction. And finally, we interact with our views. In our case, it's buttons, and we just click on it. Finally, we click to the equals button and check in GUnit way how result from our result view in this case. As you can see, it's pretty simple, and it's emulate user behavior. You don't care about any stuff which you have under the hood. You can just analyze some views, some screens, and interact with it in the same way as it do it user. Here we also can use resources, text, descriptions, etc. And really cool thing is that we can combine UIAutomator and Espresso. Of course, minimum API for this test will be 18. But it means that we have better interaction inside our application with Espresso, and we can interact with any application in system. Sometimes we would like to interact with dynamic permissions, notifications. It's impossible to test with Espresso, but we can test it with UIAutomator. Here we have samples which we start doing some actions with Espresso inside our application. And we are looking for pay button and click on it. And next step, we start use UIAutomator and display our notification, wait some time for rendering, looking for our notification and just compare if it's correct notification or not. After it, with UIAutomator, we can press click on this notification and continue test our application, use Espresso. It's really powerful combination because yes, many people write test with Espresso and don't test interaction with the system, because our application is a part of big ecosystem and we should check these interactions. And Espresso and this combination allow us to do it. It's all from my side. I hope it was interesting for you. If it's interesting, I strongly recommend spend some time for Android testing code lab. In this code lab, you will create, if I remember, notes application and test it with different type of test. And probably after it will be more clear for you. If you have any question, I will be happy to answer for all of them. I will be a whole day here, and if you have something to ask, you can always ask me in Twitter, and I hope it was interesting for you, and I'll try to help you.
Hello, thanks for the talk first. It was very good and very informative. I have only one question when it comes to synchronization of Espresso. Yeah? You said there's the message queue and idling resource and something else.
Async task.
Yeah. So my question was for the message queue. You mentioned that it's like 50 milliseconds, but we can change or something. That's kind of how do we change that? How can we change?
If I remember correctly, we have in Espresso static class which called idling policy, and use idling policy we can change this timeout.
Great, very useful. Thank you.
I have a question. Sorry, I was late at the beginning, but I'm really wondering if there is equivalence of Espresso in iOS world.
I don't know. Sorry, but I don't know.
Yeah, because it looks really cool, you know. I was wondering. Okay, thanks.
Yes, but maybe we have some alternative, because few years ago I listened some ideas that someone tried to create something like Espresso for iOS, because it's look pretty simple, and you can just interact and don't care about what your application has under the hood.
There are some frameworks.
Yeah, I don't remember the name, but I know that there is a framework by Google. They use it to test their iOS app.
Yeah. Yeah, Google know how to create UI frameworks.
Because as far as I know, all frameworks are much more complicated. This one, very easy.
Yeah.
Switch to Android.
Maybe a quick one. And how do you run it on CI?
We can use Gradle task for it. We have two tasks for running a local test. It's a Gradle task, a Gradle Vue task, and we also have a Gradle Vue CAT or connected Android test, and it allows you run all tests on CI. But when you run instrumentation test, some device should be connected, or at minimum emulator, because this test needs some device or emulator.
It depends on the CI you are running. On Jenkins, there is a plugin which allows to run emulator.
Yeah.
So for the notification, you should use better this UIAutomator or the coffee.
Espresso.
Espresso, yeah.
We should use UIAutomator. Here we can start some tests in our application with Espresso, because it will be simple. And UIAutomator has really big problem when you work with list, because for UIAutomator, some list is just set of layouts, set of views. And with Espresso, you can interact with it in simple way. And here in UIAutomator, you create UI device object and open notification, and after it do something with your notification, some check-in actions, etc.
Okay, so you can use this quick reply feature in this by UIAutomator, yes?
Yeah.
Okay, thank you.
It's also part of Android testing support library. It's almost the same. It's almost the same dependency to Espresso. And one more thing: if you use an API less than 18, you should overwrite Android manifest in an Android test folder and set minimum API version to 18. And in this situation, all your tests which use UIAutomator, you can run only on devices which has IP higher than 18. But all your, as example, Espresso test, you can run on devices with AP 8 and higher.
I have a question. Do you search by text, right? If I have 5 views with the same text.
Probably something wrong with your user experience. But you can use some resources. It's package plus your view and your ID of your view, and ID should be unique, and it solves your problem.
Because of this difference for the API, which is handled by UIAutomator, is higher, and for the Espresso, is it better to, I don't know, maybe write test in 2 different packages instead of one? I mean, do the assigning the API in manifest has any influence on the Espresso test if
No.
the API is lower? so it still will be running.
Yes, it will be running because only tests which use only UIAutomator or UIAutomator plus Espresso will not run on devices with API less than 18. You can do it in the same model, in the same class, and it will work.
So system allows you to install this test app even if the manifest is set. I mean, mean SDK is set to 18. I mean, it's higher than the API of the emulator of device.
In this case, if you use some device with AP 14 and use UIAutomator, when you have a merge Android manifest, it just will be not merge, and it means that you will have only Espresso tests.
So you don't even in Android Studio you don't get the warning that you have too low API for that.
You should add just annotations, some which API for some module, but it doesn't mean that all tests will need the same API.
Okay, thank you.
Gradle pretty smart for it.
I hope to keep it short. Well, how do you get the configurations for your AVDs, for your emulators to test a particular app? I mean, are there any guidelines for this?
First of all, you can have some. You can run some ADB commands for turn off all animations. You can also do it use ADB, and after it, you can run firstly your unit test, and if they pass, you can run your UI test.
I meant rather API level and such things, resolution or screen size, such things.
It depends on the. In case of emulators, it depends on the images you already created. So if you have prepared images, you can use it, or you can start a new one with the proper arguments during the emulator start.
But you also can use some cloud solution. We have solution from Bitbar, Google, and many others, and you can.
Okay.
I think best way is to use farm with different devices.
We use Espresso on Jenkins, and for the couple of cases we have prepared the special images of the different devices with different API screens, and for some tests we run those tests on those prepared images, and the other tests on different images. So it's your decision how do you approach this. But with the CI it is easy because you can prepare everything before you start your tests.
Okay, thank you very much, Alexander.